Welcome back to Quantitative Reasoning. In our previous tutorial, we wrote our first for loops. There weren't any mistakes in those for loops because I debugged them before I wrote that tutorial. Alas, in real life, it's common to make mistakes in early versions of computer programs. In this tutorial, we'll see some frequent kinds of mistakes when working with for loops. We'll also learn how to detect and fix these mistakes. Last time, we wrote a script that estimated the probability distribution of the number of suits in a random draw of 5 poker cards. For demonstration purposes, I've deliberately introduced a few mistakes into our script. Let's clear out our environment by clicking on the broom button in the Environment tab. When we source the script, we get an error. In the error message, R points out that it can't find the object OBS. Error messages of this kind usually hint at a missing initialization. Looking through our script, we notice that we attempt to access an element in OBS with square brackets during the for loop, but we forgot to initialize OBS before the loop. R can't access elements in a vector that doesn't exist, so let's fix this bug by inserting a proper initialization. Unfortunately, we aren't out of the woods yet. Now we get a different error message. This error message hints at a problem that R encountered when preparing a figure with a bar plot function. Error in plot.window. Unfortunately, R doesn't name the variable in the script that causes the problem. In such cases, it's a good idea to look at the Environment tab to check whether we can spot a variable with an unexpected value. There's an NA in OBS, which shouldn't be there. And why does OBS have 5 elements, although we initialized it with only 4 elements? Something seems to be wrong with the for loop. How can we trace the mistake? Here are 3 basic debugging techniques. 1. Reduce the number of iterations. 2. Inspect the values of variables during the loop with a print function. 3. If the for loop makes calls to R's random number generator, for example with the functions sample or rnorm, fix the seed before the loop so that results are reproducible. Let's apply these techniques. We reduce the number of iterations from 10,000 to 3 and insert several calls to the print function. The first call to print reveals that a new iteration has started. We also print the current value of the iterator I, the sample S that is drawn during this iteration, the number of suits N, and the values stored in OBS. Finally, we set an arbitrary seed before the for loop. We can now analyze the sequence of events in small steps. During the first iteration, we sample diamonds, clubs, spades, diamonds, and again diamonds. The next line of output shows that N has the value 5. This value is alarming because there are only 3 different suits in the sample: diamonds, clubs, and spades. So N should have the value 3 instead of 5. The following line of output shows that our code has derailed. We are trying to access OBS in square brackets 5, which we haven't initialized, so R appends NA as 5th value to OBS. We conclude that something must have gone terribly wrong when we assigned a value to N. Going back to the code, the offending assignment must be N gets length in parentheses S. Can you see what's wrong? The variable S is a sample of 5 cards, so it's a vector of length 5. Consequently, our current script assigns the value 5 to N. However, we wanted to assign the number of suits in S, not the number of cards. We forgot to include the unique function on the right-hand side of the assignment. Let's correct this mistake and source the script again. Because we use the same seed as in our previous run, we draw the same sample of cards in the first iteration: diamonds, clubs, spades, diamonds, and diamonds. In our new version of the script, we correctly assign a value of 3 to N. Looking at the following line of output, we confirm that the third element in OBS is set equal to 1, exactly as we want it. As a simple exercise, please go through the rest of the console output to confirm that the next 2 iterations also produce the expected result. When we are confident that we fixed all bugs, we should erase set.seed, revert to the old number of iterations, and remove the print functions. They are more sophisticated debugging methods than the one I've just shown you. RStudio has a menu item, Debug, that offers more advanced options. I personally hardly ever use them. For the relatively simple R scripts that we write in this course, RStudio's debugger is likely to be overkill. In summary, I recommend the following 3 basic techniques as an effective first aid kit. Reduce the number of iterations. Print out the values of variables during the loop. If you use a random number generator, fix a seed so that outcomes are reproducible. In the last 2 tutorials, we learned how to work with for loops. They are code elements to influence the control flow, that is, the order in which commands are executed. Next time, we learn another tool to regulate the control flow, conditional statements. See you soon.